We are on lesson 4-14 in Algebra 2. Today's date is January 22nd. Please put it down on your notes. January 22nd. Let's do it in blue here. January 22nd. Make sure your name is on the notes in case you leave it behind. It's the 24th. Why am I saying the 22nd?
Ooh, dude, that's like 100.
Yeah, sure. Teacher error. Give it to you. Log it. All right, so today we are doing odd and even polynomials, odd and even functions as well. We have two homework assignments tonight on Khan Academy. One of them is talking about odd and even functions. The second one is talking about odd and even polynomials. Since polynomials, you know, I guess they don't technically encompass all functions. Functions do encompass all polynomials though. So basically, this is the two things that you need to know. What happens with the equation? What happens with the graph? If you know those two things with odd and even functions, you're set for today. So I gave you 4 even functions. You know they're even because the title is even functions. I want you to spend roughly 2 minutes thinking about what's happening graphically and what's happening with the equations. What's happening graphically and with the equations. What do you notice about each of these graphs? What do you notice about each of these equations? Go ahead and write down your own thoughts now. All right, James, Chris, I'm picking on you because you haven't participated yet today. What did you two say? Who wants to go first?
Can I go first?
Yeah, go for it. What did you notice about the graphs?
Negative goes down.
Negative goes down?
Yeah.
What do you mean negative? The negative first term?
Yeah, sure.
Yeah, so like this one was negative, so it has end behavior going down. Those other 3 have, well, I guess those 2 had positive polynomials out front, so they had end behavior going up. So that's good, and that's review. But that's still good. Is there anything new that we haven't covered yet that you notice about the graphs? Chris, you can turn in your card. James, anything that you notice about the graphs or the equations? No? Okay, we'll give it to someone else then. All right, everyone can participate multiple times now. Wait, Fiona, have you participated yet? All right, Fiona, it's on you. Either one. I still don't have anything written down for my notes. What did you notice about the graphs or the equations? All right. Exponents are even, which is mostly correct. If it's a polynomial, you're correct. Notice that cosine was to the power of 1 technically, but I'll give it to you because that is exactly what I wanted you guys to see. What about the graphs? Anything else that people saw about graphs aside from the end behavior that Chris has already mentioned? Anything at all? Yeah, Sego.
So they're squiggly and they always hit the y-axis.
They're squiggly, they always hit the y-axis. You are definitely correct. They are squiggly and they hit the y-axis. I could have an even function that is not squiggly, but it would hit the y-axis. Actually, I could have a function that is not squiggly and doesn't hit the y-axis. I don't know what your definition of squiggly would be, but I could have this sharp function like this that is an even function.
You still want to notice on those graphs. If you had just a different graph like that, then
That's true. I'm just making sure that even is not defined by squiggly and hits the y-axis. So what do you notice about this function that's being added to these other functions? This is also an even function. What do you notice about it in terms of the symmetry of it?
Say that again?
In terms of the symmetry of the graphs, does anyone notice anything particular about even functions compared to maybe the odd functions? Symmetry like a butterfly. Andrea?
well, there was symmetrical on
Negative side of the x's or the y's?
Yeah, the x's.
Oh yeah, so this side and this side, they look the same. They have like the same heights if I go in the same direction, like left versus right. Yeah, and that's kind of what I want to say here. So I guess we can just say symmetry across, symmetry, English is hard, symmetry across the y-axis. The y-axis. All right, so I can't really show this with the video, but go ahead and take a look here. This is an even function. I know it's an even, I'll wait for you to finish writing so you can actually see. Symmetry across y-axis. We're basically going to be rewriting that for the star anyway, but this is an even function. We can all nod our heads. It's symmetric across the y-axis. What this means, if I have a piece of paper, is I can fold it across the y-axis, and if I hold it up to the light, that line matches up.
That's even. Or
That means it's even if I can fold it across the y-axis and it matches up. That means it's an even function. If I fold it across the x-axis, it doesn't match up with it. It doesn't mean anything. So far, so good. We understand even functions. All right. So this is what I want to say about even functions. So technically, I don't want to rewrite those two. So let's just give those their own stars. Symmetry across the y-axis. Exponents are even. There's two other things that I want to write down in the star down here, which is this. F of x, bless you, is equal to f of negative of x. This is what Andrea said, but more formally. More formally, it says the height, and let's annotate this thing. Let's add some notes to this. F of x always means height. So the height of x, which let's just say x is always positive. The height of the right is equal to the f always means height. The height of the right is equal to the height of the left. Now it's left because I have a negative x. And that's assuming that the x was positive. If the x was negative, then it changes our interpretation. But I think that's a good way of oversimplifying this. The height of the right is equal to the height on the left. And you can see that. So if I go to the same x-coordinate on the right and the same x-coordinate on the left, the heights at those 2 points are the same. We can all nod our heads. That makes sense. This equation is a little bit confusing, but it makes sense when I explain it. All right.
Are you okay, Chris?
Bless you. He's dying over there. All right. Let's talk about odd functions. Again, we're going to do the same thing. And it's a little bit easier now that I've talked about symmetry and exponents. But what do you notice about these graphs in terms of just the graphs of them, not the equations? And what do you notice about the equations? Go ahead and write down your observations. I'm going to give you 1.5 minutes, 30 seconds left. Go ahead and do that now. We're back. James, it's on you. What did you notice about those graphs? Or what did you notice about those equations? You get your first choice. Symmetrical across the x-axis. So that's saying if I folded right here, maybe I should do that in a different color so I can see. If I folded across the x-axis right here, then this would match up with, I'm not sure if x-axis is quite right, but it is a good attempt and you still get your participation card in. All right. Anyone else? Everyone else can participate multiple times. You can say either one of these things. X-axis was close. James had half of it. He's missing his other half. You want to fix it?
Y-axis.
Just the y-axis?
No.
So if I did just the y-axis, that means that this point would match with right there, which it's missing. But good attempt, good attempt. I'll give you another bout of XP. Keep trying, James. You still get your XP over and over again. Psycho, go for it.
Cross to the y-axis. Like if you have a piece of paper and you cross it to the y-axis and over to the x.
Ah, so you reflected it over the y and the x. Yeah, so it's a reflect across x-axis and the y-axis. And it doesn't matter the order. And as a visual explanation, I have some patty paper here where I've drawn this lovely odd function. I know it is an odd function because I have constructed it to be odd. I don't even know what function does this. And I'm going to wait for everyone to finish writing reflect across x-axis and y-axis so they can see this awesome demonstration. This is the best way to learn odd functions. I'm waiting for the Stephs and James. All right, so we see this patty paper. It is an odd function. If I fold across the x-axis first, that's this way, notice that it turns it into an even function. And then if I fold across the y-axis, now you can see that it perfectly matches up with the other line. Lines match each other. It's like a two-dimensional butterfly instead of one-dimensional butterfly. Make sense? Now does our heads? Good, okay. You now have the basics to figure out if it's an odd or an even function. Now let's talk about the polynomial version of that. What do you notice about the polynomial equations? Quiet raise hand. Who wants to do this one? And I think I need to go back and give Stego her XP. What do you notice about the equations? Same two people over and over again. All right, Andrea.
Odd exponents.
Yep, odd exponents. We had 2x to the power of 3, 5x to the power of 1, to the power of 5, 3, 1, 7, 5, 3, 1. All of those were odd, and therefore everything is odd about these equations. Sine is technically an odd function because it follows the rule if I reflect over the x-axis and then the y-axis that this point will match up with this point once it gets reflected. So that technically is an odd function. It's just not an odd polynomial because sine of x is not a polynomial. Not unless you do the expanded form of sine of x, but you don't do that until calculus. So the thing I'm going to write for my star is very similar to what I just wrote up here, but instead of writing f of x is equal to f of negative x, I'm going to add something additional to that. F of x is equal to the negative f of negative x. All right. So the way to interpret this thing, f of course means what? Quiet raise his hand. F of something means, we already wrote it down in our notes above. I know Andrea has her hand raised, but I'm going to call on someone else because she keeps participating over and over again. Teflon. Height, yes. Write it down. Height. And I don't mean to make that a bad thing, Andrea. I really appreciate how much you participate. This is the height. Let's assume that x is positive. Height of the, what does this mean? If it's assumed to be positive, x is the, James. Right. You are right. Teflon, wait, did I give you? No, I did not. Okay, so Teflon gets her 50. James, you get your 50. So the height of the right is equal to, and now what is this negative x telling me? Negative x is telling me, Chris? Left. There it is. Left. So Chris, get your XP. F, but negative. What is negative f? It's height, but, yeah. Height, but opposite. It's the opposite height. So instead of going up, you go down, or instead of going down, you go up. It's the opposite height on the left. And you can see how that makes sense. So let's apply this definition to our equations up here, our graphs rather. So let's randomly choose, I want to go back to yellow. Let's randomly choose this height. Well, it says if I went to this x on the right, I go to that same x on the left. I go to the same height, but instead of doing that height, I do the opposite of that height. So I come back up here, that should match up for every single point on this graph. And that is in fact what happens. So that's all I want to write there. Perfect. Let's go on to the back to do an example. We have two examples, one for graphs, one for equations. I need 3 people to volunteer to tell me if they are even, odd, or neither. Neither. It can be neither. In fact, most of the time it's neither. Very rarely is it even and odd. All right, so the first graph. Who wants to take a guess? First graph. Gio.
Even.
It is indeed even. Thank you, Gio. What about the second graph? Chris.
Neither.
Neither, yep. And the third graph? Fiona. It is odd. I keep forgetting I need to give Chris, then Fiona. Chris, then Fiona. All right, then we're on to example 2. So, now do the equations. Tell me if they're even, odd, or neither. All right, f of x. Who wants to do f of x? F of x. Stego. It is indeed odd because all of the exponents are odd. This is an invisible 1 there. So thank you, Stego. Next equation. Next equation. James. No? Is that a hand? No. Gio. Neither. That's correct. Because we have a mixture of even odds. It can't be either one, so it's neither. So thank you, Gio. And second to last, H. Even, odd, neither. Fiona. It is indeed even because every single exponent is even. And finally, James.
Neither.
It is indeed neither. Because I have a mixture of even and odd, which is neither. I always forget that R for some reason. Weird. that's all there is for the notes. 2 homework assignments. 1 looking at graphs, 1 looking at equations. Any questions? All right, that's it. Go ahead and write your summaries, and then the homework is already assigned on Khan Academy.